Hello, class. We're going to continue lectures for section 3.1, and we're going to focus on evaluating functions and equations and the functional notation. And so let's pull up the whiteboard again and define what we mean, first of all, by functional notation. I think most of you have probably seen this before, but if we had an equation like y equals 2x, say plus 3, and we say that this is a function, and I'll show you how to prove that in the next section. But if we say, okay, it is a function, then we can use this functional notation, f of x, which actually means y equals 2x plus 3. So if you think about the graphing of this, where x is here, and remember y is up here, well, that's the same as f of x. So of course, in the math world, we have to make things more complicated. We just can't leave it y, right? But what the f of x implies is that equation has to be a function, or you can't use that f of x notation. And so it's used throughout the rest of this class, and you'll see it's used throughout calculus as well. So it's important to get a feel for that. The way I look at it in my head, as I say to myself, f of x implies the vertical axis, which is just the output, which is y. So say like we had, so this is also a function. And so say like we take this equation, y equals 2x minus 3x, or 2x squared minus 3x. That is a function. So we could replace the y with the f of x, and that would be 2x squared minus 3x. So given this format, we have this way of evaluating the functions at a variety of different ways. So what we're going to now focus on is how to evaluate, and let's use this equation or function as the example. So the first one is, how do we evaluate, for example, f of 3? So that implies that wherever you see x, you want to plug in the number 3. So it's just like evaluating the equation where we said x equals 3 in the top equation, right? So you would do 2 times 3 squared minus 3 times 3. So that would be 918 minus 9. And so that answer would be 9. So there are other ways to do that. So whatever is inside here is what you plug x into. So let's say we do this one. Let's see. Get my eraser right here. So say like we plug in something like f of 3x. That seems kind of interesting and new thing. So the way that works is that wherever you see x in the function, you want to replace it with 3x. So basically write this out, 2. So here's our first x, right? So it would be 3x squared minus 3, and then that x would be 3x. So a little bit strange, but if you kind of follow the process, hopefully it's not too bad. So this would be 2, and 3x squared would be 3x times 3x, so that would be 9x squared, right? And this would be minus 9x. So to finish this, 2 times 9 is 18, so that would be 18x squared minus 9x. So let's do a couple more of these. Okay, get a feel for what's happening. So what happens if we do this? And instead of putting it inside, we do something like this. Say like we do 3 f of x. So what that implies in this case is that you want to take the value y and multiply it by 3. Or this whole equation gets multiplied by 3. So the way to look at that, that would be 3 times 2x squared minus 3x. And so when you do that, you get 6x squared minus 9x. So when it's placed outside and you're multiplying or dividing, etc., you just multiply the whole equation by, or divide the whole equation by that number. Okay, well, let's do one that you'll be doing quite a bit. What happens if you do this? Minus f of x. So what that implies is that you want to negate the function. So instead of y, we're going to do minus y, right? So it's going to be the opposite. So to do that, you take the whole equation and multiply it by minus 1. So it looks like that. And so that would be minus 2x squared plus 3x. So basically, you're just changing the sign of each one of the terms. What we're going to do next is different than what we just did here. Say like we, instead of doing that, we are going to plug in minus x. So what does that mean? Well, again, wherever you see x, you're going to replace it with minus x, and then you're going to do the algebra on it. So that minus doesn't go out front here, it gets replaced in each one of these. And this one's a little tricky, so watch what I'm doing here. So we have a 2 here, and then we have the minus x, and then that gets squared, right? And then that's minus 3 times minus x. So it's important to get your parentheses. Remember, you're replacing the x, and so the square goes on top. And so minus x times minus x implies 2 negatives, right? So that would be 2x squared again. So that one doesn't change. But you could see here a minus times a minus gives us a plus. So this one gives us plus 3x. Okay. So let's do just a couple more of these. Come on, eraser. And so say like you do something like this. Say like you wanted to take the function and add it to, say, f of 3. So f of x here, we're not changing, right? So that's just the same equation, x squared minus 3x. And what we mean here is wherever we see x, we're going to plug in the number 3. So that would be plus 2 times 3 squared minus 3 times 3. And we did that before. If you add all this up, what do we get? It would be 18 minus 9, which is 9. So our solution would be actually taking that equation, original equation, and adding 9 to it at the end. So the last one we're going to do, and we're going to talk about this quite a bit more in the next lecture. And there's this one's probably one of the more complicated ones, but say like we did this. F of x plus h. And you'll see there's a little method to the madness when we talk about difference quotients, which is the next lecture. So in this case, you replace x with the whole thing, x plus h. So let me walk you through this, and let me walk you through the algebra as well. So you would have 2, and then replace x with x plus h, and this one's squared, right? And then you have minus 3 times x plus h. So with regards to that, we want to expand this out. And remember, this is x plus h times x plus h. And when you expand that out, you would get x squared plus 2xh plus h squared. So this would be 2 times x squared plus 2xh plus h squared. And this would be minus 3 times x plus h. So the next step is distribute the 2 through here, distribute the 3 through here. And so that would be 2x squared plus 4xh plus 2h squared minus 3x minus 3h. And so the last step would be combining like terms. And you see here that there are no like terms. They're all unique, so there's nothing to combine. So this would be your final solution. And we're going to take that x plus h thing to the next level in our next lecture. But this is concludes the section of the lecture where you're finding values of a particular function given these equations.